Right, here are the solutions to the Lesson 3 practice problems. Number 1, we're supposed to complete this table, use powers of 64 in the top row and radicals or rational numbers in the bottom row. So 64 to the first is 64. 64 to the 1/2, we've learned now that that means we're taking the square root of 64. So we would put an 8 in this bottom row here. 64 to the 1/4 is the same thing as the square root of 64. Then to get 4, we know that 4 cubed is 64, and so the cubed root of 4 would be, the cubed root of 64 it would follow that that's equal to 4, and then we know that the cubed root can be written as a number to the 1/3 power. So I would write 64 to the 1/3 in this box. Anything to the 0 power is 1, so we just put a 1 down here. When we go from a 64, a power of 64, to a fraction, we know that our exponent must be negative, so 64, and then since it's 1/8, we know that we took it to the negative 1/2 power. So we shifted it into the denominator and took the square root, basically. So let me just write this out here so you can read it. And then, so 64 to the 1/2 is equal to the square root of 1/2 of 64, which is 8. But if we change this to a negative now, then we know that that shifts it down into the denominator, and we have 1 over the square root of 64, and so then that's 1/8. And then similarly, the next one, if we have 64 to the negative 1/2 power, or negative 1 power, that's just shifting the whole number 64 into the denominator. So that's what our new table looks like, with those powers of 64 and the radicals or rational numbers in the bottom. Suppose that a friend missed class and never learned what 25 to the 1/2 means. Use your exponent rules that your friend would already know to explain how to calculate 25 to the 1/2 times 25 to the 1/2. Well, from studying exponents in middle school, we know that when we have like bases or the same base, we can add exponents. So this would be 25 to the 1/2 plus 1/2. And that would be 25 to the first. And so 25 to the 1/2 power is just 25, times 25 to the 1/2 is just 25. And then they want us to explain why this means that 25 to the 1/2 is equal to 5. So we can say, since 25 to the 1/2 from part A times itself is 25, we got that from that, then 25 to the 1/2 is 5, because 5 times itself is 25. Number 3, which expression is equivalent to 16 to the 1/2? So what we learned about rational exponents is that 16 to the 1/2 is the same as the square root of 16, and so we would choose letter B here. Number 4, select all the expressions equivalent to 4 to the 10th power. So some of these have base 2, so I'm going to try and rewrite these with base 4. And then just follow our rules of exponents. So for the first one, if I would add these exponents together, I would get 2 to the 7th, which if I could break that down into now base 4, I would just want to break it down into as many 4s as I could get. And so that would be 4 to the 3rd, since each of these is 4. So I'd have 4 to the 3rd times 2, or 4 to the 1/2. So that's not going to give us 4 to the 10, though. 2 would be 4 to the 1/2. So I'd have 4 to the 3rd times 4 to the 1/2, which would just be 4 to the 3.5. The next one, however, if I wrote these all out as 2 squareds, in other words 4s, if I wrote this out and use my exponent rule when I'm adding exponents of same bases, I could write this 10 times, and that would be equal to 2 to the 20th. So eventually I would get 4 to the 10th power, because each of these would be 4 and I would have 10 of them. So this one is an equivalent expression to 4 to the 10th power. The next one, just using our law of exponents here with the same base, I would have 4 to the 4 plus 6 here, and that would be 4 to the 10, so C works. I guess I could circle the whole thing there. Part D, 4 to the 7th times 4 to the -3rd would be 4 to the 7 plus -3, which is 4 to the 4th, so I can't include that one. Letter E, I could rewrite this and subtract exponents since I'm dividing power terms with the same base. So I would have 4 minus a -6, which would be plus a +6. So this one would be 4 to the 10th. So this one is also an equivalent expression to 4 to the 10th. Number 5, the table shows the edge length and volume of several different cubes. So remember, the volume of a cube is just side squared. Or, I'm sorry, 5 cubed. We'd take length times width times height. So if this is my cube, I would have this side times the height, like that. And they're all the same since it is a cube, so it would just be side times itself 3 times, which is side cubed. So if we have an edge length of 3, we would have a volume of 27, since 3 times 3 is 9, times 3 is 27. If we have a volume of 64, hopefully by now you're kind of memorizing that 4 cubed is 64. 85 isn't a perfect cube, and so what I would do here is just write the side length as the cubed root of 85, because I could take the cubed root of 85 times itself 3 times, which would be 85 to the 1/3 times 85 to the 1/3 times 85 to the 1/3. And that would be 85 to the 1/3 plus 1/3 plus 1/3, which is 85. So we would get this volume if each side was the cubed root of 85. Similarly, the cubed root of 100 is the side length. That means we would take another way to write this, and I'll show you this one with the next example here. If I have the side length that is a cubed root of 100, I can write that as 100 to the 1/3, and then if I take that times itself 3 times, remember we multiply exponents when we raise a power to a power, so this would be 100 to the 3/3, or 100. So when we multiply the cubed root of 100 times itself 3 times, we get 100. The cubed root of 125 for this side length would be 5. 5 times itself 3 times is 125. And if we have an edge length of the cubed root of 147, that means our volume is 147, because that times itself 3 times would just kind of lift those that radical symbol off the number there. Number 6, a square has side length 82 centimeters and square centimeter, the square root of 82 centimeters, so the side length of a square, and we're talking area of a square now. So remember, if we have a square, it means all sides are the same, and we would just multiply side times itself to get the area. So the area of a square is just side squared, and so we would take the square root of 82 times the square root of 82, which is 82 to the 1/2, times 82 to the 1/2, which is 82 to the 1, which is 82. One way of looking at it, so letter B would be your choice here. Another way you could do it is actually multiply underneath here. And when you do that, the square root of 82 times the square root of 82, we'd have to multiply 82 times 82. We'd get the square root of 6,724. And then if you let your calculator do the work for you there, you'd get 82. So many different ways to look at these, and we're just brushing up on our knowledge of exponents in this lesson. So that's it for this week, this first week of quarter 3. I hope that helped.